Worldwide, an estimated 500 billion to 1 trillion plastic bags are used each year. This has been a global issue that contributes to various environmental problems, including harm to wildlife, damage to ecosystems, and the acceleration of climate change. On average, each person on Earth uses approximately 83 plastic bags annually. These bags are commonly used for carrying groceries, packaging food, storing items, and lining trash bins. But how and where these plastic bags came from? The production of plastic bags begins with the extraction of non-renewable fossil fuels such as crude oil or natural gas. These resources are obtained through drilling operation, which may occur on land or at sea. This phase contributes significantly to environmental degradation, including habitat disruption, carbon emissions, and potential oil spills. After extraction, crude oil is sent to refineries where it undergoes fractional distillation, which is a process that separates it into various components. One crucial byproduct of this process is naphtha. Naphtha is a volatile, flammable liquid hydrocarbon that serves as the main raw material for making plastics. In the next stage, naphtha undergoes steam cracking, where it's heated with steam at high temperatures. These break down large hydrocarbon molecules into smaller ones, producing ethylene, a gaseous hydrocarbon that functions as the foundational monomer for polyethylene plastics. Through a process called polymerization, ethylene molecules are chemically bonded under controlled conditions, typically high pressure and temperature, to form polyethylene resin. These resin exist in various forms depending on polymerization method. Low-density polyethylene is characterized by flexible and lightweight properties, which is ideal for grocery bags. On the other hand, high-density polyethylene is more rigid and durable, used in retail and merchandise bags. Once polymerized, the polyethylene is cooled and cut into uniform resin pellets.
These polyethylene resin pellets are delivered to the manufacturing plants where they are melted and extruded through a circular die, forming a continuous thin-walled plastic tube. Air is then injected into this tube, inflating it into a large bubble through a process called blown film extrusion. This method produces a consistent and uniform plastic film. As the bubble ascends, it is cooled and gradually flattened by rollers, resulting in flat, double-layered plastic sheets. After cooling and collapsing, these sheets are cut to predetermined sizes and sealed, typically at one end to create the basic form of plastic bags. Depending on their intended use, manufacturers may add design elements such as side gussets, perforations, or die-cut handles to enhance functionality and branding. Additionally, plastic bags are often customized with printed logos, promotional content, or barcodes using flexographic or digital printing technologies. After printing and cutting, the plastic bags are carefully counted, bundled, and packed into cartons, preparing them for large-scale distribution. These cartons are then transported from manufacturing plants to distribution centers worldwide. Due to the global nature of plastic bag production, various stages such as resin manufacturing, extrusion, printing, and packaging often take place in different countries or regions. This fragmented supply chain contributes to the overall carbon footprint of each plastic bag, mainly through emissions generated during transportation.
These plastic bags are supplied in large quantities to various retail outlets, ranging from large supermarket chains to neighborhood convenience stores. Consumers typically receive these bags at the checkout, using them briefly to carry their purchases. Plastic bags are a common part of daily life, most often used to carry groceries and retail items. Their lightweight and moisture-resistant properties make them convenient, and many households repurpose them as liners for trash bins or for waste collection. However, Once discarded, plastic bags pose significant environmental challenges. Improper disposal often leads to plastic bags being carried by wind and water into natural habitats where they contribute to pollution and threaten wildlife. The majority of these bags ultimately end up in landfills where they degrade very slowly. Over time, they can release leachate, a toxic liquid capable of contaminating soil and groundwater, particularly in poorly managed landfill sites. Recycling presents a viable solution, yet only approximately 5% of plastic bags are recycled. Contamination from food residues or paper receipts complicates the recycling process. To address this, plastic bags are sometimes submerged in water, allowing paper to sink while plastic floats. The clean plastic is then shredded, melted, and converted into pellets that serve as raw materials for new products. Despite their practicality, plastic bags carry a substantial environmental cost. Reducing their use, enhancing recycling efforts, and developing alternative materials are critical steps toward achieving greater sustainability.